Assalamualaikum and good morning. Can you hear me? Anyone? Assalamualaikum and good morning.
Waalaikumsalam. Good morning, Doktor.
Waalaikumsalam.
Okay.
Good morning, Doktor.
Alhamdulillah ada orang. Okay. So baru 31 tolak saya. So it should be 50 plus kot. So never mind lah, kita start. Okay. Kalau tunggu lambat ni pun dah lambat 15 minit lah. Okay. What we are going to do today is that today will be our last lecture for this subject, CMA 534 for my part. So for this last lecture, I'm going to cover a topic on long span roof structures. Okay. Okay, can you see my slide?
Yes.
Yes,
Okay.
Doktor.
Siapa open mic ni? Okay. Alright. So I mentioned just now, today we are going to move on to our last lecture, which is on long span roof structures. Okay. So as a recap, 2 weeks ago I already give to you an introduction to long span structures, which involve 3 common structural systems, which are long span beams, long span trusses, and also today we are going to cover on long span roof truss structures. Okay, so last week I already prepared a few pre-recorded videos on long span beam and also trusses, and I also attached a few videos for you to watch in order for you to get a better view on long span beam and also trusses. So I hope you have watched all the videos, and if you have any question, you can ask me later, okay, during the session or maybe the groups as well. Okay. So for long span roof structures, okay, this is the outline. Okay, we are going to have a look on the types of long span roof structures, which involve portal frame, dome structures, shell structure, folded plate, and also tensile structure. Okay, there are 5 types of long span roof structures. So as introduction, the name itself, the roof, okay. The roof itself, which is the most essential parts of a building, is the covering of on the uppermost part of the building lah. I believe you know where is the location of the roof, which is on the top of the building, the uppermost of the building, and that protect the building its content from the effects of weather. Okay, for example, rainfall, heat, sunlight, cold, and wind, depending on the nature and intended design of the building lah. Okay. And the span of a roof is a major consideration among other factors, including functional requirement and consideration of speed and economy of erection. Okay, so in order to select the type of roof that you want to use in your building or in your project, the span of the roof is one of the factors that you need to consider. Okay, selain daripada function, okay, speed and economy of erection. Okay, so span of the roof is one of the factors that you need to consider. So the span of the roof can be classified in relative terms as short, medium, and in our case kita focus on long span, which is mostly over 25 meter lah. Okay, so ada juga yang between 10 to 20 meter pun sometimes we call it as a long span roof. Okay, so types of long span roof structures as I mentioned just now, we have 5: portal frame, domes, shell, folded plate, and also tensile structure. So we have a look. We are going to have a look on each type of long span roof structures after this. Okay, starting with portal frame. Okay, so portal frame were first developed during the Second World War and became popular in the 1960s. Okay, so it's already a long time ago. Portal frames has been widely used in the construction industry. Okay, so they are now commonly used to create wide open enclosures where a clear space is required uninterrupted by intermediary column. Okay, if you require a wide span punya space without interruption of intermediary column, okay, kena nak kurangkan numbers of column, so you can adopt portal frame as your structural system or as your roof structure system in your construction project. Okay, so they are originally used because of their structural efficiency. Okay, meaning that large spaces could be enclosed with little use of materials for a low cost. Okay, they tend to be lightweight and can be fabricated off-site. Okay, lightweight and can be fabricated off-site means that when you use portal frame as your roof structures, most of the material used are lightweight and also can be fabricated off-site, means that they are encouraging you to use IBS. Okay, so the component then will be bolted to a substructure. Okay, kita punya foundation dan sebagainya lah. If you remember during the lecture on steel framing system, okay, I show you a method statement to develop a simple a small project which is a 2-story building using steel framing system. Okay, that's part of the component lah. Okay, the bentuk portal frame. And the portal frame themselves may be left exposed to the internal space. Okay, so sama juga lebih kurang macam steel yang kita belajar itu. Okay, most of the component will be exposed for aesthetic value. Okay, to become more attractive and so on lah. So material used for portal frame can be steel or steel reinforced precast concrete, and although can also be constructed using glulam. Okay, sama ada kita guna steel or glulam as our portal frame. That's of the component used. But in Malaysia, mostly we are using steel lah. Okay, as our roof structures for portal frame. Okay, glulam ni kurang lah in Malaysia, tak banyak lagi. Okay, masih still new. Okay, types of portal frame, we have a few types of portal frames. One of them is pitch roof symmetric portal frame. Okay, the difference is the layout of the roof structures lah. Okay, ni dia ada curves a little bit, and normally is suitable for 25 to 25 meter. Okay, dia punya span. In term, the second one is portal frame with internal mezzanine floor. Okay, whereby we include what we call it as a mezzanine floor inside our portal frame. So normally this type of portal frame being adopted in factory building, whereby you want to have an office in your building. Okay, so we can create what we call it as a internal mezzanine floor. Okay, and we also have crane portal frame with column brackets. Okay, so kita masukkan ada column bracket guys tu for traveling crane. Okay, it's movable. Okay, you can move around. Okay, so this one to the right and to the left. Okay, so this is as you all know, normally portal frame is being used on a warehouse or factory building. That's why, as you all know, most of the factory needs this traveling crane for their production processes and so on. And the next one, we also have mansard portal frame. Okay, so as you can see, dia punya cross section dia dah a little bit ada few edges lah. Okay, so dia punya eave height need to be minimized lah. Eave height dekat sini. So over here, sometimes there is a requirement of a certain design. They ask you to have a large clear height and mid span. Okay, tengah-tengah ni dia nak clear height. That's why we can adopt what we call it as a mansard portal frame. So dia little bit higher lah on this one. And we also have curved rafter portal frame. Okay, so a little bit curved here. So, but this one is limited to 20 meter, maximum 20 meter lah. But if you require a design that more than 20 meter, so maybe you can carefully design whereby you can require splices. Splices ni maksudnya cut into small pieces. Okay, so maybe satu pieces tu 10 meter, sambungkan dan seterusnya. Maybe boleh go more than 20 meter lah in that case. Okay, kalau 20 meter saja satu panel sudah cukup. Okay, and we also have cellular beam portal frame. Okay, as you remember last week, this is one of the type of long span beam. Okay, we are talking about cellular. Okay, ada hole dekat framing dia ni. So one of the reason is for aesthetic reason and maybe again for M&E punya purposes lah. Okay. Right, this diagram is going to show you the components involved in portal frame. Okay, as you see, there are a lot of components involved. Okay, and normally what I would like to emphasize here is about the bracing. Okay, whereby normally when you use portal frame as your structural system or even as your roof structures, you need what we call it as a bracing, okay, to increase the strength and stability of your portal frame. Okay, so again, if you still remember masa steel framing system, I also mentioned about bracing ni, okay, to give strength and also stability to your portal frame. Okay, so because normally portal frame ni we are going to connect it with using bolt and nut, and also some part using welded connection. Okay, so perhaps sometimes the bolt and nut connection will be loose one day, or the welded perhaps will be decreased. The strength of the welded connection will be decreased in the near future. So perhaps by having a bracing, we can give extra strength and stability to our portal frame. Okay, next types of long span roof structures is domes. Okay. So dome is created from multiple arches or vaults which are connected in a symmetrical manner to form a sound structural entity. Okay, dome bases are usually circular but may exhibit other shapes as well. But normally kebanyakan dome ni dalam bentuk circular lah, dia lebih kurang bulat macam ni. Okay, domes has a long architectural lineage that extend back into prehistory, and they have been constructed from mud, snow, stone, wood, concrete, metal, glass and plastic over the centuries. Okay, so dah lama dah these structures has been around during prehistory ataupun during before World War I and II as well. Okay, so dah lama dah sebenarnya daripada guna mud, snow and from day to day is already the usage of the material used for constructing the dome has been improvised. So banyak sekarang kita dah pakai even pakai glass, pakai metal and so on. And a dome can be considered as a three-dimensional arch form. Okay, and a dome is an architectural element that resembles the hollow upper half of the sphere. Alright, so dia macam lebih kurang bentuk separuh lah, half of sphere ni. Alright, so many old buildings such as Blue Moss, the Sistine Chapel and the Pantheon use the dome as their roof. have a look on this short video on usually the dome will be constructed or fabricated at the ground level lah. Okay, kita pasang ke sel-sel kat bawah tu baru kita naikkan ke atas. Okay, so that's one of the example of the construction of the dome lah. Okay, so usually we fabricated it on site, from ground level sampailah kita naikkan ke atas. Only using, as you can see just now, using tower crane, and they are using lightweight punya steel, so it's quite easy to install lah. Okay, there are variety types of dome structures available. Okay, one of them is rib structure. Okay, so these rib dome structures can be said as can be said to be an innovation of the rigid frame. Okay, we can see it as a three-dimensional form of the rigid arch frame. Okay, as you can see here. Okay, the rib dome structure consists of arrangement of rib members. Okay, this is what we call it as a rib members. Okay, on a rim beam. Okay, near ring beam. Okay, so that converge on either a crown connector or a crown compressor rings lah. Okay, so dia punya connection here, over here. So the ring beam support is needed to prevent splaying of the RIP members. Okay, so dia kena give extra support. They function as a secondary beam to make sure that the RIP members ni tak it's not being expanded. Okay, tak lari lah dia punya projection ataupun dia punya length. So supaya kita boleh type the RIP members ni within the sizes that has been given in the drawing specification lah. Okay, so we call it as a RIP members ni as a extra component lah. Okay, rim beam support ni. Okay, ataupun kalau dalam steel framing dalam steel flooring system normally you use what we call it as a secondary beam as a support. So dalam ni pun kita ada what we call it as a rim beam support. Then the column and load bearing wall support the rim beam. Okay, so we can install column and load bearing wall to support the rim beam ni. And the RIP members are constructed of hot roll steel section or cold roll steel or aluminium sections lah. Okay, so you're using steel. Okay, sama ada lightweight or heavyweight steel can be used, and of course we can use aluminium as our RIP members ni lah. Okay, yang longitudinal ni is RIP members. And we also have a grid dome structures. Okay, so this dome type is innovated from a flat grid roof type. Okay, so kita innovate and come up with this grid layout. So the grid framework is curved to provide the dome shape. Okay, so again the different kalau you tengok is more or less the bentuk little bit macam diamond pun ada. Okay, so the dome can either be a single layer or double layer grid structure. So the type of grid can be either a lattice grid or a space grid. Okay, depends on the design. So and then after that, after you install the roof structures ni, then you can cover the roof with steel sheet, geotextile, fiberglass, or polyester, ceramic panels. Okay, depends. Okay, you can attach it either to the purlins fixed on the grid member or tied to the grid members lah. Okay, sama ada you install dekat purlin atau directly tied to the grid members of the dome structures ni. We also have a lamella, okay, lamella dome structures. Okay, so the lamella dome is a type of grid roof. At first sight, the lamella dome structure looks like grid dome. Okay, lebih kurang quite similar, but the difference is the connection. Okay, grid kita sambung guna connectors. The component being connected using connectors. Okay, while untuk lamella ni kita guna pin jointed. Okay, guna pin jointed ni maksudnya bolt and nut lah. Okay, so yang ini different little bit dia punya connection system. And then there has a variety of shape. Okay, ada yang bentuk diamond, rhombus ataupun triangular grid pattern. Okay, but grid lamella ni more unique lah, okay, compared to grid. Next we have geodesic dome structure. Okay, so this one is grid loop. It's look like lamella grid domes, but the difference lies in the configuration of the grid lines. Okay, again dia punya grid lines ni berbeza lah. Okay, compared to grid and also lamella tadi. Okay, so geodesic ni a little bit different. Dia punya grid lines. Okay, so the grid line follow the pattern of points of intersecting geodesic lines of the dome lah. Okay, so dia lebih ada more lines compared to lamella and also grid line. Okay, a geodesic line is defined as a line that circumvents the surface of the sphere. Okay, circumvent ni maksudnya bypass. Okay, kita bypass the surface. Okay. So the point where geodesic line crisscross each other are called geodesic points. Okay, so the members of geodesic frame are not geodesic, but the position of the connection are geodesic. Okay, so where geodesic itu bila kita ada connection lah, itu yang dia punya geodesic. So the grid members are either double or single layered. The members in geodesic dome are joined together without using connectors components. Okay, again they are using pin jointed lah, macam lamella as well. Okay, there is a short video on geodesic. Okay, so that's the example of the geodesics lah. Okay, the way they connected the just now we are using wood as their material. Okay, so they are connected the rafters. They're using the connectors. And next, another types of long span roof structures is shell structure. Okay, shell structure is a thin curved membrane or slab usually made of reinforced concrete, which can function both as a roof covering and also structures. Okay, shell roof typically composed of concrete panel curve cylindrically or spherically to achieve greater strength. Shell roof is basically the modification of a pitch roof and covers large areas of the building. Moreover, shell roof is 3D structures consisting of a thin membrane slab curved in one or more directions, which transfer the loads on point of support. Okay, column, beam, and wall, etc. Okay, whatever attached to the shell roof, that's the way the loads will be transferred. And the shell roof are built with several materials, okay, such as in situ concrete, timber, steel, sheets, ceramic, glass, plastic, hardboard, lattice, and composite structures. Okay, so there are varieties of material that can be used as shell roof lah. Okay, sama juga macam dome tadi. Okay, even though they're using wood, tapi dia punya covering tu dia using wood shingles and etc. Okay, shell belongs to the family of arches. Okay, they can be defined as curve or angle structures capable of transmitting loads in more than two directions to support. Okay, a shell with one curve surface is known as vault or single curvature. A shell with doubly curved surface is known as a dome. Okay, double curvature. Okay, so basically more or less shell dengan dome ni ada dia punya similarity lah. But again, basically the shell structure is more stronger than dome lah. Okay. Okay, the single curvature can be divided into two: long span barrel vault and short span barrel vault. Okay, for the long span, act primarily as a beam. Okay, the span of which is the length of the vault. Okay, the shell constitute the compression member, and the edge beams the tension members of flange. Okay, the maximum economic span is about 30 to 45 meter, and the width usually not more than 50 meter. Okay, the width, this one, less than 50 meter. Okay, so for short span, used when the clear span is beyond the practicable or economic limits of a long span barrel. Okay, so it's an option. Kalau kita tak boleh construct long span, we can use a short span. So end frames in the form of arch ribs, rigid frame or bowstring are usually spaced 9 to 12 meter apart, and sometimes up to 18 meter. Okay, so dia punya dimension tu a little bit shorter lah. Okay, and while for double curvature, it's either part of the recipe or hyperboloid of revolution. Okay, as you can see, this is what we call it as hyperboloid. Okay, so the 3D geometrical surfaces. Okay, the term single or double represent to distinguish rigidity of the two forms and complexity of centering necessary to construct the shell form. Okay, and it may be considered as a series of arches and suspension cables intersecting each other at right angles. Okay, so it can be in the form of hyperbolic or saddle shape form. And this type of surface has greater resistance to buckling than dome forms because of its shapes lah. Okay, as I mentioned earlier. Alright, so normally shell structure is more stronger than dome structures lah. And then we have folded plate. Okay, folded plate structures are assemblies of flat plates or slabs inclined in different direction and joined along their longitudinal edges. Okay, so it's a flat rata, but dia ada shape yang sama ada cara kita nak connect dia mestilah selari. Okay, what we call it, that's what we call it as a longitudinal edges lah. Edges tu mesti parallel atau in selari. Okay, sama. Okay, tak boleh lah different angle. And by constructing this folded plate, the structural system can carry loads without the need for additional supporting beams along mutual edges. Okay, so tak perlu nak ada support beam macam kita gunakan just now apa tadi, domes ataupun portal frame lah. Okay, kita kena ada bracing dan sebagainya. Alright, this technique originated in Germany in the 1920s and became popular in Russia and the United States during 1930s to construct roof for industrial warehouses and also public buildings. Okay, so modern folded plate structure are typically made of cast in situ or precast reinforced concrete or steel plate. So again, we are talking about the integration of IPS in the roof structures of folded plate. Okay, so we're using steel or maybe we can use precast as your folded plate structure. And there are variety of shapes and form of folded plate. Okay, ada 3. Okay, the first one we call it as a prismatic, which is in the rectangular plate. Okay, so dia ada bentuk rectangular lah little bit. And we have pyramidal, okay, non-rectangular plates. Okay, dia ada some sort like triangular little bit lah. Okay, tapi tak adalah macam betul-betul prismoidal ni. Okay, triangular plates. Okay, so it's variety of shapes and forms that you can use for folded plate roof structures lah. It's not limit only for certain design saja. Okay, here are some of the application of folded plate in real project. Okay, this is one of the example, Air Force Academy at Keppel in US. Okay, the architect is Walter Netsch. The length is 280 feet, the height is 150 feet, and the width is 84 feet, and it's been built in 1962. Okay, we also have Yokohama International Passenger Terminal. Okay, this one is for terminal in yard lah, for ferry and so on. The floor area is almost 35,000 meters square. The length is 430 meter, height is 50 meter, and the width is 70 meter. Okay, this is the model lah. Okay, of this passenger terminal. Okay, using folded plate roof structures. Okay, so yang ini kalau you tengok is more on yang ketiga tadi apa? Okay, it's more on I think pyramidal kot yang ni. Okay, yang ni one more on prismatic yang pertama, type yang pertama lah. Okay, dia lebih bentuk rectangular. And the last type of long span roof structures is tensile structures. Okay, a tensile structure is a construction element carrying only tension and no compression or bending. Okay, so I think last week saya dah attach one video with the comparison between tension and also compression. Okay, tension is something that pull and compression benda yang push, menekan. Okay, so dalam nak gunakan tensile structure is only focusing on the tension member. Okay, benda yang menarik. Okay, so tensile structure is the term usually used to refer to the construction of roofs using a membrane held in the place of steel cable. Okay, so we push the membrane using steel cable. Okay, their main characteristics are the way in which they work under stress tensile and their ease of fabrication and the ability to cover large span and their malleability. Malleability ni more on flexibility. Okay, atau the word is flexibility. Okay, flexible. So this structure also known as a cable net structure. Okay, such a structure consists of a set of catenary cables suspended from supporting members and secured by guys, anchor elements, compression rings or compression arches. Okay, that's among the component yang kita boleh secure the cables lah. Okay, this cable support a lightweight of roof covering materials such as fabric, polycarbonate plastic, lightweight ceramic tiles, and etc. Okay, the span can be up to 260 meters as in the case of Georgia Dome in US. Okay, dia boleh sampai 280 meter dia punya structure. The types of tensile structure, the first one is suspension structure. Okay, the suspension structure is being used in order to prevent wind flutter due to lightweight covering material, and the principal cable is pre-stressed by one of these method. Okay, pre-stress maksudnya kita boleh tight the cable sama ada using doubly curved system of cable or using bracing ties, using spreaders or using compression straps. Okay, so here the example. Okay, doubly curved system, as you can see, so dia ada dua layer of apa nama ni, cable system dia lah untuk tarik, pull, pre-stress the roof structures ni lah. Okay, this is what we call it as a doubly curved system. Okay, we have bracing ties. Okay, they're using bracing. Okay, to tie ataupun to to pull the roof structures. Okay, and then we using spreaders. Okay, so here what we call it spreaders. Okay, to make sure that the roof covering has been pulled accordingly. And the last one, we are using compression strut ataupun compression ring. Okay, so this is a ring. Then kita pull every angle of the roof covering. Okay, that's what we call it as a suspension punya structures lah. Okay, ada 4 types yang kita boleh apply, okay, to pull the roof covering. We also have a pneumatic structure. Okay, another name for these structures is air stabilized structures. Okay, the roof consists of a thin flexible membrane stabilized by pressure air. Okay, this is what we call it as a membrane. Okay, air pressure induced tensile structure in the membrane, thus enabling it to support loads. Okay, so the air pressure must be enough to prevent compressive stresses developing in the membrane such that the membrane will tear. Okay, so kita kena make sure the pressure must be sufficient enough in order to avoid the membrane from being teared. Okay, atau koyak lah. Right, there are 2 types, air supported structure and air inflated structure. Okay, for air supported structures, this consists of a membrane which encloses a space by using air pressure. Okay, we are giving the structures an air pressure. Okay, so the air pressure will be slightly above the atmospheric structure. Okay, so educate, encourage for membrane must be provided to counteract uplift forces, means that the membrane structure kena anchor to the ground lah. Okay, maybe to the foundation, maybe to the steady column and so on. And air pressure loss through excess opening is further minimized by using air locks or air curtains lah. Okay, and this is the example of the air supported structures. Okay, so the inflated air, okay, throughout the space supaya the membrane ni dia akan mengembang, okay, maintain pada shape yang kita nak lah. Okay, so of course the membrane ni will be anchor to the ground lah. Okay, so macam ni dia anchor dengan more on this the air pressure punya tools lah. Okay, they blow the air inside the space supaya dia boleh macam kita tiup balloon lah. Okay, lebih kurang macam tu. Okay, tiup balloon tu lain, itu inflated. Ini macam kita give kalau nampak biasa apa ni, some sort like orang-orang ke dekat shopping complex ke yang bergoyang-goyang tu, benda tu kita panggil dia, itu contoh air structures lah. Okay, so kita blow the air inside the space. Okay, while air inflated structure, kita dah masuk siap-siap dalam dia. Alright, ini macam balloon lah. Okay, ini macam balloon. Okay, kita put the air into the structure. Okay, so that's the difference. Okay, kalau tadi kita sentiasa give air pressure inside the space. Tapi untuk air inflated, kita kita dah masukkan angin siap-siap air inside like a balloon. Okay, this is the example of air inflated structure. Okay, in Tokyo Dome. Okay, and also in this is a Silver Dome in US. Okay, ini dah siap-siap dia put air inside the structure. And next, we also have a cable stay roof structure, mostly being used on a bridge or on stadium. Okay, this one is Benfica Stadium in Portugal. Okay, a lot of stadium in UK also use this cable stay roof structure, like for example like Wembley, Old Trafford and so on. So cable stay roof structure use inclined cable for support flat or slightly dome roof lah. Okay, so this structure yang support the roof covering ni. So these cable are attached to one or more towers, and some roof the cable run over one or more towers to encourage use in the ground. Okay, the ground encourage just maybe either heavy ballast or anchor piles. Okay, ini yang kita anchor, kita ikat the apa nama dia ni, cables ataupun the roof structures ni. A tower can support roof deck span of 25 meters, and the cables of a cable stay structure are in tension and carry the dead load and any live load of the roof lah. Okay. Some of the example: Millennium Dome, London, 1999. Okay, being built in 1999. The dome is 320 meter in diameter and 50 meter height at its center. Okay, dekat center dia paling tinggi maximum 50 meter. Okay, the fabric structure is suspended from 1200 meter high steel mast held on a net of more than 20 km of a high strength steel cable. Okay, ni dipanggil high steel mast. Ada 12 semua sekali. Benda ni yang memegang structure of the roof fabric ni. Jadi kabel kat sini kalau you perasan, kabel ni semua total 70 km. 70 km. Okay, tie the tarik the roof and tie it to the steel mast. Okay, the roof fabric is self-cleaning PTFE coated glass fiber with a minimum life of 25 years and which can be renewed in section if necessary. Okay, so there the possibility kalau one section damage, dia boleh replace. Means that you not necessary to replace all the roof fabric. Two-layer fabric provide insulation to prevent condensation. Okay, so tension steel cable are arranged radially on the surface and held in place at the knots by hanger and tie down cable at 25 meter intervals. Okay, the 24 concrete anchor blocks positioned around the perimeter of the dome resist the outward pulls of the radial cable. Okay, so that this one, the 24 concrete anchor. Okay, the foundation of each anchor extend over 25 meter into the ground. Okay, so that's how they constructed this Millennium Dome, London, 1999. And the last types of tensile structure is TEN structure. Okay, this structure also called as a tensile membrane structure. Okay, the roof structure consists of a fabric. Okay, this one fabric, and that is pre-stressed from a central column support. Okay, the atas ni central column support, and then to its anchor edges or directly to its anchor point. Okay, edges ni they support by encourage lah. Okay, the effect make the fabric behave as a membrane in tension, and the main construction problem of TEN structure is to obtain the desired pre-stress level into all areas of the fabric surface. Okay, it's very difficult. Okay, nak pre-stress the membranes lah, nak make sure dia punya shape is being developed accordingly. And the span can be as much as 12 meters from mast to anchorage, and there are several types of TEN structures using fabric. For example, this one fabric, or they can using cable reinforced fabric TEN as well. Okay, so that's the types of long span roof structures that you need to know lah. Actually, there are many types of long span roof structures. But what I include in the notes is that commonly used around the globe lah. Also in Malaysia, some of them, especially the dome, as you can see, some of the in shopping complex, okay, in the mosque, we have the construction of dome. Okay, any question? 31 orang saja ni. Mana yang lain? Okay. If you don't have any question, perhaps after this session, you can go to your UFuture, go to learning activities as usual. Okay, go to long span roof structure. Okay, lecture 10. Okay, let me start now. There are 5 videos saya. Okay, there are 5 videos that I attach here to give you more understanding about long span roof structures. Okay, there are construction method of portal frame, construction method of dome structures, an example of amazing shell structure. Okay, folded plate structure made from timber. Okay, an example of tensile structures. Okay, so there are 5 videos here. So after this session, you can straight away watch all this video. Okay. All right. As today is our last class, there is no more class next week. Okay, next week I give you time for you to maybe to complete other assignment, or maybe you can spend the time to do your revision because you are going to have an exam in February. Okay, dah dapat jadual?
Belum.
Belum. Okay. So I'm not sure, maybe around next week kot, perhaps you get the timetable. And I believe your paper is on around February. Maybe I think if not mistaken, I think early February kot. Kalau tak silap saya lah. Alright, so the exam will be conducted using UFuture. Okay, so I hope you dah familiar dengan UFuture. So perhaps exam nanti dekat continuous assessment ni, you go to, saya masih presenting kan, okay. You go to assessment, okay, dekat sini nanti akan ada, alright, soalannya. Alright, so in terms of time, I will discuss with Dr. Ani berapa lama nak give you time to complete the exam. Later on I will when we decided in terms of the timing berapa jam nak bagi you, I will inform in the group lah. Okay, so the paper will be divided into 2 parts, part A and part B. Part A is my part and part B is Dr. Ani. Betul ke part A saya? Okay, either one lah. Okay, so there are 3 question each. Part A ada 3 soalan, part B ada 3 soalan. Compulsory for you to answer all. Jawab ketiga-tiga. Okay, tak ada pilihan. Alright, for my part, 3 question. There are 2 question from IBS and 1 question from long span structure. Okay, so itu bahagian saya lah. Dr. ni saya tak sure lah pembahagian soalan ni. Tapi bahagian saya 2 soalan IBS, 1 soalan pasal long span structures. So 3 soalan, jawab 3-3. Okay, ada soalan? Okay, make sure you all when you want to do revision, of course dekat learning activities ni saya dah include the video. You can watch all over again many times. Nak tengok berpuluh kali pun boleh, tak ada masalah. And make sure you watch sebab ada, bila saya track, ada yang masih belum tengok lagi. Last week punya video. Okay, kita tengok 3B. Kita tengok lecture 10. I'm not sure you dah tengok ke ataupun sistem ni. Ini yang hari ni. Sorry. Lecture 9 last week. Okay. Jenelin. Ada? Saya kuasa tadi nama dia. Ada tak? Ni. Jenelin Narkiso. Where are you? Have you watched the video of lecture 9? Nor Azran.
Belum.
Okay, no wonder masih pangkah kat sini. Okay. So yang mana dah tick ni, dah tengok lah. Yang mana belum tick ni, not started yet. Okay. So even masa lecture 2 pun, kita bagi contoh kelas A pula lah. Kelas B je. Anish Syahira. Video 5 masih tak tengok. Okay. Fioren, video 3 masih tak tengok. Okay, ini tak tengok langsung ni Muhammad Swaizat. Betul ke tak tengok langsung ni? Ke sistem, saya takut sistem ni tak update ke apa ke? Tapi ni lecture 2 ni. Muhammad Suhaizat ada? Ke tak ada ini? So please watch all the videos. Kalau you tak nampak, tak tengok video, perhaps you tak boleh nak dapat more understanding. And of course every session saya recorded and saya attach the link dekat sini. Yang mana saya record, saya dah attach link kat sini. You just click saja dekat online class ni. Okay, untuk today pun saya akan attach the link later bila saya dah upload dalam YouTube lah. Okay, yang mana saya tak ada link ni, maksudnya ini dah memang record siap-siap lah. You boleh tengok balik dekat apa nama dia ni, learning activities dia ni. Okay, so please for those yang belum tengok video, tengok balik, tengok betul-betul supaya you clear, untuk you faham, give you better understanding on the related topic and will prepare you well for exam later lah. Okay. So ada soalan? Anyone? Kalau tak ada, we can end up the session today. So please, after we end the session, straight away you can watch the video, sebab kelas you ada sampai pukul 11, you still have time to watch the video. So please watch the video. Yang mana tak tengok video-video yang lepas, boleh tengok yang selepas-selepas ni, sebelum you face the exam. So for your carry mark, saya dalam proses lagi nak check. Perhaps I try during this prep before exam, saya boleh bagi you carry mark you berapa lah untuk your assignment. So I try before exam, perhaps masa study week tu saya dah boleh bagi you the carry mark. Okay, give you the carry mark. Okay, so pada yang tak ada ini, yang tak datang ni, please remind your friends. Okay, today is last class, next week you do your own work, and exam ada 3 soalan each part, kena jawab 3-3. Please remind again your friends lah. Again, nanti dalam group saya akan remind again lah. So, okay, bila we decided the timing and so on. Okay, so that's all. Thank you for your time and commitment. Take care and stay safe. Assalamualaikum.
Waalaikumsalam. Thank you, Doktor.
Thank you, Doktor.
Waalaikumsalam. Thank you.